it going? Okay. Being the guy that I am, I forgot to tape, so I'm taking my own time. Got to tape 6 hour. At the end of 6 hour, I had to listen to me teach in the corner all by myself. So you can look up these websites. I did share them with the students. This one website was. I woke up at like 4 in the morning thinking, how so is there some sort of scale about what these R values are? And in relation to how strong or weak or whatever. And two different websites had the same scale there. So I just thought I'd share that. That was just for fun. Back in the day with CAT students, I would say 0.9 or negative 0.9 would be a strong linear. Then anything less than that or smaller, maybe we should try another function to see what mirrors the data, blah, 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 blah. But I don't know, I thought that would be a thing that I could share with you. Then another thing is this website, which is the other link. So what are we doing today? Yesterday we found an R value, and that was just for a sample. Now what we wanted to do is try to draw a conclusion about populations. That's what all hypothesis testing is. From a sample, can we say something about everything or everybody? Can everyone say rho? Rho is the variable that somehow they use for their alternative and null hypothesis. Like I said, we're just giving you a quick smattering of all these different things. So hopefully when you go into a college stats class. By the way, that last website was from Penn State, which is a college. Some sort of listing from their class, stats class. So thought that was interesting. You could read more on that. So that second link. All right, so real fast. Hypothesis testing. Again, you could stop me in YouTube again. I'm trying to get this video done fast because blah, 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 blah. Here's the null hypothesis. Rho equals 0. For some reason, that means there's no significant linear correlation. That means from the sample, you can't say there's enough evidence to say all people emulate what the sample is showing. And then the alternative hypothesis, rho is not equal to 0. I don't know. That means there's a significant linear correlation. Let's just get these two things down and then get this formula down. Pause the video because I'm going to move on. And I have. Okay, so there we go again. And then here's a poor 6 hour. Look at 6 hour. Did it again. Forced all these things without being able to show it appear all at once. But we did all this handiwork here, all of it. And then we put the numbers in this formula color-coded. All right, and then we got that R value. Because what I'm going to do is use this. All right, this is only a sample of 6 people. From this, we do see a strong negative linear correlation between age and percent of income. Is this strong enough? Maybe I shouldn't say the word strong, but is this sample maybe large enough with a significant enough of an R value to say all people show this behavior? A linear relationship between age and percent of income donated. So that's why we do a hypothesis test. Now, here we go. It's already screwed up. Nothing I can do about it. Incompatibility of two programs. So pretend you don't see any of this. You can, I know. So using the example from the correlation notes, test the claim that there is a significant linear correlation between age and percent of income. I should have put for all people, total population, rho, donated to the charity at alpha equals 0.05. So we got that R value. Boom. And then this is the setup. I'm going to let you be lazy a little bit. What you really should say for the null hypothesis is there is no significant linear correlation between age and percent of income donated. And then for the alternative hypothesis, there is a significant linear correlation between age and percent donated. We're going to test that claim at 0.05. And then the first formula thing I wrote down is degrees of freedom, 6 minus 2, which is 4. It's a t-test. It's a Federmact. It's a t-test that is two-tailed. So what you have to do is go to your t-chart now. I'm not going to pull that up. It's a t-test. Pull up the t-chart. And it's a two-tailed because of the not equal to in the alternative hypothesis. Okay, so when you find t star, looking at row 4, underneath the two-tailed 0.05, you should get plus minus 2.776. So what it does is designate where the rejection of H sub O region is and where the fail to reject. Then you find T through this new formula specific to this type of question. Plug in the numbers. I firmly suggest you do this denominator first and get this decimal. Then divide these two decimals. All right? Then press enter and you get this, which is way over here in the reject H sub O. If you reject H sub O, then you support, here these come in, pretend they just came in now. Then you support H sub A, which is your claim that there is a significant linear correlation. So that's what you write at the end. And then what I told my students at this point is get out your homework, class, because this is what we can do next. The problem with this is, hey, good, it doesn't show everything. PowerPoint's working between the two programs. Do not write number one down the question. Do not write the chart down like you did yesterday. Go to your calculator. If you're an Inspire, then you have to hit Documents or New Document, List and Spreadsheets. You put this in A, this in B. And then what you do is just like you did for one variable stats, except now you do it for two variable stats. For 84, stats, edit, L1, L2. I'm going to let you do this now. I don't want to see those long, drawn-out charts that you had to do yesterday. Of course, people that are absent, yesterday's homework better have that. You are a bum, and I will give you a 0 on your homework for using these buttons. I have to treat you the same as everybody else. It's only fair in life. Yes, I'm looking out the window. Don't worry about it. Next. Now you can calculate two variable stats. This is awesome. Instead of one variable stats, we can do two variable stats. I just checked this yesterday. I'm like, hey, what if it does do this? And I found out it does. And all these next three screens is just the same screen scroll down. So two variable stats, watch the highlighting. That's the sum of the x's. That's the sum of the x squared. That's the sum of the x squareds. We know there's 12 data points, but there it is. And I tried to color code the highlighting first hour with how it matches to our crazy R formula from yesterday. There's the sum of the y's, there's the sum of the y squareds, and then there is the sum of x times y. Got it all. So now what I expect you to do is this. Don't write one. Don't write the chart. Go to your calculator. You obviously don't have to write these calculator screens down. But I do want you to write these 1, 2, 3, 4, 5 values down. Plus there's 12 sample coordinates. And then you could type those numbers in or write them down on your piece of paper. And I will expect to see those Inspire people. You will write these numbers down in this fraction or you will be suffer the wrath of Mr. Samuelis's red pen. Okay, so write this down, this down, this down, this down, this down, maybe not 12. Okay, but then I see 12 and then 37, 24, the blue. That's why I color-coded these as such. Red and maroon kind of look too close to each other, but they're not. If you look at my notes, it looks a little bit better than in class. Blah, 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 blah. And what you should end up getting from this crazy formula is the R value. So let's reiterate. The only thing I should see written is what's highlighted, this, and then the R value. There it is. So then from this R value, is this, okay, fine, there's a significant negative linear correlation between, if you read that question up there, the number of hours you watch over the weekend of TV compared to your test scores that coming Monday. So now, from that 12 sample size, from 12 students, is that enough to say something about all students forever, both in the past, future, whatever? Too much TV gives you a negative relationship with test scores. So if I wasn't going to let you be lazy, you'd say the null hypothesis is there's no significant linear correlation between number of hours watched and test scores. Alternative hypothesis, there is a significant, you could say negative, linear correlation between the number of hours watched and test scores. We were asked to test this at a 0.05 level in the question. There's 12 coordinates. Degrees of freedom are 10. Looking up the t-score off of these two values, you should see a plus minus 2.228. Then the next thing I should see all this. Couple, you know, I already said that. So then I should see this, and then I should see the numbers plugged in, and then be careful. I think you'd be really smart to do the denominator, then numerator divided by denominator. And then yet again, we have almost a similar scenario to the last one. This is way on the left of negative 2.228. We reject this. We fail to reject what is actually our claim, that there is a significant negative linear correlation between. So reject H sub O. You don't necessarily have to write that. I definitely need to see this though. There is significant evidence that there is a strong, you could say negative, linear relationship between, and then first hour I stopped because we didn't actually read the question. We just went to the chart. So what you should write next is between the number of hours of TV you watch over the weekend and your test score that coming Monday. Right? Short and sweet. You can rewatch. I went fast. So 2 and 3, I made it easier for you to do what we did yesterday. And I think that's fine because it is kind of a long process. Okay, boom, boom, boom. One with that.